Hello, this is Mr. Huber, and in this lesson we're going to continue looking at solving linear systems using elimination. If we look at the system of equations that we have here in this example, if we add or subtract them just as they are, neither variable is going to eliminate. Neither one's going to cancel out. They have different coefficients, so adding them or subtracting them alone is not going to work. What we need to be able to do here is multiply one or possibly both, in this case just one, of the equations. As long as we multiply the entire equation, in this case by 2, we'll get 2x plus 4y equals 10. One of the keys is to make sure you multiply the entire equation by whatever you're going to multiply by. Why did I pick 2? Well, because now the second equation that's just staying the same has a minus 2x. So I identified that if I multiplied the x in the first equation by 2, I would get 2x. That will allow me to add these two equations together and get one of the variables to eliminate. So if I add these equations now, because a 2x plus minus 2x will cancel out. And now 4 plus 5 is 9y equals 18. Again, adding across the entire equations. And then now I can divide by 9 and get y equals 2. And then I can plug that 2 back into either of my two original equations. I'm going to pick the first one because it's already got the x without a coefficient there, so that's a little bit helpful. So I'll have x plus 2 times 2 equals 5. That's x plus 4 equals 5. When I subtract 4 on both sides, I get x equals 1. So my solution would be 1, 2. Right, it's an ordered pair, x, y. We could check that by plugging the 1 and the 2 in for x and for y into both equations, make sure it works. Let's just check it in the second equation just to see. So I'd have negative 2 times 1 plus 5 times 2 equals 8. That'd be negative 2 plus 10 equals 8, which is 8 equals 8. That checks. And again, I could plug it in the first one. I need to make sure it works in both equations. Okay, but remember, that's how you can check your solution to make sure that it works. So again, if we have a system of equations where neither variable will cancel at the beginning, we might need to multiply one or both of the equations before we can add or subtract and then have the elimination kick in then. So let's see a couple more examples. So first, just looking at this, let's see what equation do you think you'd multiply and what would you multiply it by? So if we look through the 2 and the 7, negative 2 and 7, if you multiply 2 by something to get 7, you'd have to multiply by 3.5, 3.5. You don't really want to have to multiply by that fraction or decimal. That's going to make it a little more complicated. If we look at the y's, we have 15 and minus 5. So we should be able to identify that if I multiply that 5 by a 3, then I'll be able to eliminate the y's. Okay, so my first equation is just going to stay the same, minus 2x plus 15y equals negative 32. In my second equation, multiply everything by 3. And 17 times 3, which is 51. Now I'm going to add these two equations together, right? Because negative 21 plus 21 will be how that eliminates. Again, or excuse me, 15 plus negative 15 will eliminate. 15 plus negative 15 will eliminate. Negative 2 plus 21, okay, is 19x. And since the 15 and the minus 15, since they're the same number with different signs, I add them. If I add opposites, they'll cancel out. Equals, and then negative 32 plus 51 is 19. So when I divide both sides by 19, I'll get x equals 1. Okay, we solve for x first here. That's fine. Now I'm going to plug that into either of my two equations for x. It doesn't matter which one you use. I'll pick the second one this time. Last time we used the first equation. It doesn't really matter. So I'm going to do 7 times 1. Here it might be a little easier without the minus 2x. Anytime you can work with positive numbers, that usually will help. Although we have a minus 5 here, so it's not too different anyway. So I've got 7 minus 5y equals 17. When I subtract 7 on both sides, I'll get minus 5y equals 10. Divide by negative 5. And and I get y equals -2. So my solution will be 1 comma -2. Again, I would want to check that by plugging in 1 for x and -2 for y into both equations. Make sure it works. Okay. Let's have you try one out here. Check out this system. Figure out, again, if you add or subtract the way they are, nothing's going to cancel out. Try it out, pause the video, and then replay it when you're ready to see how your solution looks. Okay, now that you've had a chance to try this equation out on your own, this system out on your own, we look through and we can see that if I multiply the 5 times 4 and then I have 20, well, that should give me 20. So I might want to multiply this first equation by 4. Okay, that's going to give me 20x plus 8y equals 16. And my second equation is just going to stay the same, 20x plus 8y equals 8. Okay? And so now, 20x and 20x, I need to subtract those. 20 minus 20 will be what cancels out. And then I'm going to have 8 minus 8y, that's going to cancel out. And I have 16 minus 8, which is 8. So what am I going to have on the left side of my equation? Okay, this isn't x equals 8 or y equals 8. It's 0x, really, right, plus 0y. When we cancel out, it's because there's zeros. We're going to end up with 0 equals 8. Okay? 0 never equals 8. So this is no solution. All right? Remember, in elimination, when both variables cancel out, look to see if you have a statement that's true or not. If we ended up with something that said 0 equals 0 or 8 equals 8, that's always true. It would be infinitely many solutions. But this is never true, so no solution. Let's take a little pause here. A Cartesian question. Okay, the XY coordinate plane is called the Cartesian coordinate plane. It's named that way for the mathematician René Descartes, who in the 1630s started to develop the coordinate plane. Okay, he was working on it at the same time. Pierre de Fermat was also working on that as well. And it started by looking at a number line. Okay, so if we see a number line, right, we can be familiar with that. Right, we have 0, then we'd have 1, 2, 3, -1, -2, -3, and so on. Well, then they decided, well, we could put another axis, another number line going up and down, right? We do 1, 2, 3, and -1, 2, 3, all right? So we have this coordinate plane now. It's really just 2 number lines, one going left to right, one going up and down, all right? But so why do we use x and y for these? Why do we call this the x-axis and the y-axis, all right? Well, the common convention in math has always been to use letters at the end of the alphabet for unknowns, for things that we don't know. So we're thinking, well, what about Z, right? Wouldn't Z be really the end of the alphabet? Why wouldn't you use Y and Z? Well, part of that was because at the time that they were coming up with this coordinate system, right, they developed it in 3 dimensions. So the 3-dimensional coordinate plane looks like this, where there's a third axis, which would be the Z-axis. So there's really an X, Y, and a Z-axis when we talk about things in 3 dimensions. All right, and you could have an X, comma, Y, comma, Z. So Z is that third dimension. X and Y are when we just have the horizontal and vertical axis. So that's why we use X and Y typically to indicate those axes. Again, we've talked before, you can use any letters you want, but the standard ones we normally use are X and Y, and that is Y. All right. Let's look at some more systems by elimination. Again, let's have you pause the video to try this out and then see how your solution comes out. Okay, now that you've had a chance to look at this, you might have thought, well, what could I multiply 3 by to get 4 or 2 by to get 3? And there's going to be some difficulty here. Part of the reason for that is, if you remember at the beginning, we said sometimes you might need to multiply one or both equations. So in this case, we need to figure out, let's say the 3x and 4x. If I want to get those both to be 12, for instance, right, I can multiply this whole first equation by 4, and I can multiply this whole second equation by 3. Okay? And I'd have 12x plus 8y equals 4. And I have 12x plus 9y equals -6. And then I could solve that. If I subtract 12x minus 12x, will cancel out. Right? You don't necessarily have to do it that way. Okay? You could also multiply to eliminate the y's. Okay? So if we want to multiply to eliminate the y's, we could multiply this first equation by 3. And the second equation by 2. So I can get them both to be 6y's. I'd have 9x plus 6y equals 3. And I'd have 8x plus 6y equals -4. And you could subtract those as well. So let's just do it that way since that's what we have written, but you could solve it the first way, and that would work as well. Okay? So remember, we're going to subtract the entire second equation. 9 minus 8 is 1x. 6 minus 6y cancels out, equals 3 minus -4, positive 7. That's 3 plus 4. You're subtracting a -4. That's adding 4 to the 3, which is 7. Now that we have x equals 7, we can plug that back in. It doesn't matter which equation. Let's just pick the first one. All right, so we have 3 times 7 plus 2y equals 1. That's 21 plus 2y equals 1. We can subtract 21 on both sides. We get 2y equals -20. Divide by 2. And we get y equals -10. So our solution then would be 7 comma -10. So be aware of where you might have to multiply both equations. You can multiply by anything you want. You can multiply the whole first equation by 10 if you want. It's not really going to help solve anything, but you could. So you can multiply as long as it's the whole equation by any constant that you want to. All right. Let's take one more look at something here, a word problem. Okay? You're selling tickets to a basketball game. Adult tickets cost $5 and student tickets $3, and we know how much money we collected, $630, and how many tickets we sold, 170. So we want to write two equations based on this. And the first thing we want to do is define our variables. So I'm going to say x equals adult tickets. Okay? And we're going to say y equals student. Okay? So the two things we know are, one, we sold 170 tickets. So that means if we have x plus y, we're going to get 170. Or we add up the number of tickets for adults, the number of tickets for students, and it should come out to 170. The second equation we want to write is based on the amount of money. That's going to be a 5x, because it's $5 for every adult ticket plus $3 for every student ticket equals 630 total dollars. Okay? So one equation based on the number of tickets, x plus y equals 170. Another based on the amount of money, 5x plus 3y equals 630. And if I'm going to solve these, if you want to use any method, you could. You could use graphing, you could use substitution. We're going to use elimination here to continue practicing that. So I can multiply the whole first equation by either 5 to eliminate the x's or 3 to eliminate the y's. It does not really matter. I'm going to pick 5. So if we multiply this whole first equation by 5, I'm going to have 5x plus 5y equals 170 times 5, okay, which is going to come out to 850. Okay. And then my second equation is going to stay the same. And now I need to subtract these equations, right? I want to get the 5x minus 5x to cancel out. 5y minus 3y is 2y equals 850 minus 630 is 220. So now if I divide by 2 on both sides, I'm going to get y equals 110. Now I can figure out what x is. I'm going to use the first equation because it's got x plus y, no coefficients in front of either one, so that should be relatively easy to plug into. So I'm going to get x plus 110 for my y equals 170. And if I subtract 110 on both sides, I'll get x equals 60. So we want to use these to answer the question. Don't just say 6 comma 110. Okay? So adult tickets, that's the 60. So 60 adult tickets and 110 student tickets. Okay? So that means they sold 60 adult tickets, 110 student tickets, based on that information we were given at the problem. One equation based on the number of tickets, one based on the amount of money, and we can use those together to solve the system. All right, and make sure you go back and you use that information to answer the question that was actually asked. All right, so remember, when you're solving a system by elimination, one thing you might have to do is to multiply one or both equations, okay, to be able to get one of the two variables to eliminate, to cancel out when you add or subtract them.